Welcome to MRL. In this learning session, we'll be learning about the Power Play or the Exponents of 8th grade Ganita Prakash textbook. Now here I have a list of the syllabus which we'll be learning in different videos of this chapter. Now if you read the syllabus, we have repeated multiplication, repeated addition, multiplicative growth, exponential notation, general form of exponents, parts of exponential notation, exponential form of a number, expanded form of exponents, numerical value of exponential form, laws of exponents, application of laws of exponents, combination of objects, 5 digits, log codes, simplification of exponents, prime factorization in exponential form, linear growth or additive growth, scientific notation, expressing large numbers in scientific or standard form, expressing small numbers in scientific or standard form, expanded form of numbers in powers of 10, expressing lakhs, crore, million, billion, trillion in powers of 10, operations on exponent form of large and small numbers, expressing large distances, values and time in exponential form in powers of 10. So the list is exhaustive list, and all these will be discussed in different videos. The syllabus is discussed and explained in multiple videos for all to learn. The solutions of the questions on each page of the chapter will be available in videos form, and for all to understand, and also to understand the applications of basics of the topic in solving and answering the questions. The topic is an important part and useful for various entrance and competitive exams. So therefore, learn this chapter thoroughly, understand every basic of what is given in each of the videos, and learn them, understand them. So now let us begin with the videos. Welcome to MRL. In this learning session, we'll be learning about exponential notation. Now what is exponential notation? Exponential notation is a method of representing repeated multiplication. What does that mean? So let us say we have 2 multiplied 6 times. That means 2 is multiplied 6 times here. Instead of saying that 2 is multiplied 6 times, there is repeated multiplication of 2 6 times, we can write it as 2 raised to 6. Now 2 raised to 6 is the exponential form of 2 having been multiplied 6 times. So the repeated multiplication of 2 with itself 6 times is written in exponential notation form as 2 raised to 6. In this, 2 is called as the base and 6 is called as the exponent or power or index. Therefore, remember, in an exponential notation there are 2 parts. 2 is the base and 6 is the exponent, and it is read as 2 raised to the power 6. Please remember, 2 raised to 6 is read as 2 raised to the power 6 or 2 to the power of 6. Now the generalization of this would be, if a is multiplied n times, then we can write it as a raised to n, where a is the base, n is the exponent, and it is read as a raised to the power n or a raised to n. So please remember that. Now we have an example here. 3 is multiplied 4 times. So therefore the exponential notation will be 3 raised to 4. The base is 3, the power is 4, or the exponent is 4. But also if you pair the 3's here, we have 3 into 3 is 9, 3 into 3 is 9, that is 9 into 9 is 9 square. So we have 9 square. So 3 square raised to 2. That means one pair of 3, another pair of 3 becomes 3 square and 3 square, and raised to 2 becomes 9 square. Here the base is 9 and the power is 2. That means 81, which is 81 can be written as 3 raised to 4, or 81 also can be written as 9 raised to 2. That means the same number 81 can be expressed with different bases and different powers. That is what we have to remember. Same number can be written with different bases and exponents. So 81 is written as 3 raised to 4 here, base is 3, power is 4. 81 is again is written with base 9 and power 2. Remember that. Exponential form and the expanded form. 10 raised to 3 is exponential form, and 10 into 10 into 10 is the expanded form. Here 10 raised to 3 means 10 is multiplied 3 times, and this is the expanded form of 10 raised to 3, or this is the exponential form of 10 into 10 into 10. So we have to know to write the exponential form as well as the expanded form of any given number. Now 1 by 1000. 1 by 1000 can be written as 1 by 10 into 1 by 10 into 1 by 10, which is 1 by 1000. That means 1 by 10 is multiplied 3 times here, and that can be written in the exponential form as 1 by 10 raised to 3. Similarly, 1 by 1024, it means that 1 by 2 into 1 by 2 into 1 by 2 is multiplied 10 times, and which can be written as 1 by 2 raised to 10. So therefore, we can convert any number in exponential form in this method. Now here, 1024 is 2 into 2 into 2 is multiplied 10 times, and therefore the exponential form is 2 raised to 10. And to find the exponential form, just divide 1024 by its prime numbers or prime factors. We get this here. We have divided 1024 by 2. We have got 10 2's here, and that is the exponential form of what 1024, which is 10 raised to 2. Remember that. Now the laws of exponents are very, very important for us to understand, and very useful in calculation exponential forms. Now the first important law is a raised to m into a raised to n is equal to a raised to m plus n. So please again let me repeat, a raised to m, that means a is multiplied m times here, again a is multiplied n times here. When we take the product, then it is the same as a raised to m plus n, rather a is multiplied m plus n times. Now let us take one example and understand it. If I find out 2 raised to 10, that is 2 is multiplied 10 times, I get 1024. But I get 1024 by multiplying 16 and 64 also. But 16 is 2 raised to 4. That means when I multiply 2 4 times, I get 16. When I multiplied 2 6 times, I get 64. If I take the product, I get 1024. That means 2 raised to 4 into 2 raised to 6 is 2 raised to 10. That means, but here, that means 2 raised to 10 is equal to 2 raised to 4 plus 6, and that is 1024. Whether I take 2 raised to 10, it is 1024. But if I find 2 raised to 4 and multiply by 2 raised to 6, I get 1024. Or rather 2 raised to 4 plus 6 times is also 1024. Therefore we can conclude that a raised to m into a raised to n is equal to a raised to m plus n. That means a multiplied m times, again a multiplied n times, taking that product is nothing but is equal to a raised to m plus n, rather a is multiplied m plus n times. Remember this, a very important law and useful for calculations. Now the second law. The second law states that a raised to m divided by a raised to n. Again I'll repeat, a raised to m divided by a raised to n. That means a is multiplied m times here. When divided by a multiplied n times, we get a raised to m minus n. Rather, it is nothing but multiplication of a m minus n times. But here m is greater than n. Now to understand this, 2 raised to 6. 2 raised to 6 is 64. When I multiply 2 by 2 6 times, I get 64. And also when I multiply 2 10 times, I get 1024. I multiply 2 4 times, I get 16. When I divide 1024 by 16, I get 64. That means what I have done here is I have divided 2 raised to 10 by 2 raised to 4. 10 minus 4 is also 6. That means again we get 2 raised to 6. 2 raised to 6 is equal to 64. What it implies is that 2 raised to 10 divided by 2 raised to 4 is nothing but 2 raised to 10 minus 4, which is 2 raised to 6 and 64. So whether I take 2 raised to 6 is equal to 64, that means it makes us clear that a raised to m divided by a raised to n is a raised to m minus n when m is greater than n. If m is less than n, it will be 1 divided by a raised to n minus m, which is important for us to remember. Now the third law, a raised to m raised to n is equal to a raised to mn. Now what does this mean? That means here a raised to m is multiplied n number of times, and the value is nothing but a when multiplied mn times. A is multiplied mn times. Now let us take one example here for understanding. 3 raised to 12 is equal to 3 raised to 6 plus 6. That means 3 is multiplied 6 times, and again 3 is multiplied 6 times. When we take the product, the value is 3 raised to 12. So the value of 3 raised to 12 or 3 raised to 6, multiplication of 3 raised to is the same. That means 3 raised to 6 into 3 raised to 6 is nothing but 3 raised to 6 is multiplied 2 times, therefore 3 raised to 6 to the power of 2, and 6 into 2 is 12, and that is 3 raised to 12. So whether I multiply 3 raised to 6 2 times or 3 raised to 6 into 2 or 3 raised to 12, the value is the same, and therefore a raised to m raised to n is equal to amn. That means a raised to m here, 3 raised to m or 3 raised to 6 into 2 is 3 raised to 12. So also instead of 3 we have taken a here, instead of 6 I have taken m here, instead of 2 I have taken n here. So a raised to mn, a raised to m raised to n is equal to amn. The meaning of this is that when we multiply a raised to m n times is the same as multiplying a mn times. So that is what is the law, and a very important law for us to remember. Now the next important law is a into b raised to m is equal to a raised to m into b raised to m. That means the product raised to any power is equal to the product of the powers of the individual numbers. That means if I have 10 raised to 4, 10 raised to 4 is 10 into 10 into 10. The prime factors are 2 into 5, 2 into 5, 2 into 5. That means 2 is multiplied 4 times, 5 is multiplied 4 2 multiplied 4 times is 2 raised to 4, 5 times is 5 raised to 4, and 5 is multiplied 4 times, therefore it is 5 raised to 4. Then 2 raised to 4 into 5 raised to 4 is 2 into 5 raised to 4. 2 into 5 raised to 4 is nothing but 10, and that is 10 raised to 4. So that means expressing 10 raised to 4 as 2 into 5 and raised to 4 is the same as 2 raised to 4 into 5 raised to 4. Therefore the law is very much proved here. That means a into b raised to m is equal to a raised to m into b raised to m. That means multiply a into b and raise it to power, we get the same value, or multiply a m times and then multiply by b multiplied by m times, the answer is the same, and therefore a into b raised to m is equal to a raised to m into b raised to m. A very important law to remember. Now the very next important law is a by b raised to m is equal to a raised to m by b raised to m. Let us take an example to understand or prove this law. 3 by 4 raised to 5. The expanded form of this will be 3 by 4 has to be multiplied 5 times. So 3 by 4 into 3 by 4 5 times. So now when I take the product, then I have to take the product of the numerator and the product of the denominator. The product of the numerator is 3 into 3 3, that is 5 times, 4 into 4 into 5 times, therefore it is 3 raised to 5, 4 raised to 5. That means 3 by 4 raised to 5, the value is the same as 3 raised to 5 divided by 4 raised to 5, which concludes that a by b raised to m is a raised to m by b raised to m. So please remember that. Now the next law is 2 raised to 5 divided by 2 raised to 5. Let us understand this. 2 raised to 5 divided by 2 raised to 5 is equal to 1. And you know that the numerator and the denominator are the same. When we divide, we get the value 1. Now 2 raised to 5 divided by 2 raised to 5 can be written as 2 raised to 5 minus 5, because using the law that a raised to m by a raised to n is equal to a raised to m minus n. Therefore 2 raised to 5 divided by 2 raised to 5, here a is 2, m is 5, n is 5, 2 raised to, that is a is m minus n. So 2 raised to 5 minus 5 becomes 2 raised to 0, and 2 raised to 0 is 1, because 2 raised to 5 by 2 raised to 5 is 1. Therefore the LHS 2 raised to 5 by 2 raised to 5 is 1, and 2 raised to 0 therefore has to be 1. If you have to generalize it, instead of 2, let me take it as a. Therefore any number raised to 0 is always 1. Remember that. The next law, that is a raised to minus n is equal to 1 by a raised to n, or 1 by a raised to n is equal to a raised to minus n. Let us take an example here. 1 by 32. 1 by 32 can be written as 2 by 64, and 2 by 64 is 2 raised to 1 upon 2 raised to 6, and we can apply the law that a raised to m by a raised to n is equal to 1 by a raised to n minus n, because n is greater than m here, and therefore we get 1 divided by 2 raised to 6 minus 1, and that is 1 by 2 raised to 5. That means 1 by 32 is 1 by 2 raised to 5. Now 1 by 32 also can be written as 2 by 64, which is 2 raised to 1 by 2 raised to 6. We can apply the law a raised to m by a raised to n is equal to a raised to what we call m minus n, that is 2 raised to 1 minus 6. 2 raised to 1 minus 6 is greater here, that is minus 6, 1 minus 6 is minus 5, so 2 raised to minus 5. That means 1 by 32 is 1 by 2 raised to 5, or 1 by 32 is 2 raised to minus 5. That means 2 raised to minus 5 is equal to 1 by 2 raised to 5. That means a raised to minus n is equal to 1 by a raised to n, or 1 by a raised to n is equal to what? A raised to minus n. That is what you have to remember. Therefore, the important laws of exponents are a raised to m into a raised to n is equal to a raised to m plus n. A raised to m divided by a raised to n is equal to a raised to m minus n if m is greater than n, or a raised to n minus m when if n is greater than m, or it can also be written as 1 divided by a raised to m minus n. A raised to m raised to n is a raised to mn. a into b raised to m is a raised to m into b raised to m. A by b raised to m is equal to a raised to m b divided by b raised to m, and a raised to minus n is 1 by a raised to n, and a raised to 0 is equal to 1. And these are very, very important laws for us to remember to solve the examples based on exponents. Now these laws can be used to solve examples. The exponents can be positive or negative. Okay, remember that. Now prime factorization in index form. If you have to express 96 in index form, prime factorization or the index form, then divide 96 by prime factors. So 2 48s are 2 24s are 2 12s are 2 6s are and 2 3s are and 3 1s are. So we got 1 2 3 4 5 2 raised to 5 into 3 raised to 1. So the prime factorization of 96 is 2 raised to 5 into 3 raised to 1. So that is the importance of exponents here. 144. The prime factorization of 144 is divide 144 by the prime factor 2. 72s are 144, 2 36 are 72, 2 18s are 36, 2 9s are 18, 3 3s are 9, 3 1s are 1. So we got 1 2 3 4 2s. So 2 raised to 4 into 3 raised to 2. Therefore the prime factorization of 144 is 2 raised to 4 into 3 raised to 2. Now application of laws of exponents, I have taken one example here to understand how we can apply laws of exponents for solving examples. There are innumerable examples to be solved, and this is one simple example I have taken for us to understand. So let us say an example, let us consider an example here. Simplify 25 raised to 2 into 6 raised to 3 into 2 raised to 9, 8 raised to 4 into 5 raised to 3 into 9. Now observe here, 25 is a composite number, 6 is a composite number, 8 is a composite number, 9 is a composite number. So first of all, write the prime numbers of each of the composite numbers here. 25 can be written as 5 square, 6 can be written as 2 into 3, and 8 can be written as 2 cube, 9 can be written as 3 square. Now 25 is 5 square square, 2 into 3 cube, 2 into 9, 2 raised to 9, 2 cube raised to 4, 5 cube, 3 square. Now apply the different laws of exponents and simplify. 5 raised to 2 raised to 2, that means 2 into 2, that is a raised to m, a raised to m raised to n is equal to amn. Apply that. So 2 to the 4, 5 raised to 4. 2 raised to 3 into 3 raised to 3. Again I have applied the important law of exponent here. A into m raised to n is a raised to n m raised to n. So apply that here. 2 raised to 9 as it is. 2 raised to 3 raised to 4 become 3 into 4, that is 12, and 5 raised to 3 as it is, and 3 square is 3 square as it is. Now we have 5 raised to 4, 2 raised to 3, 3. So now please add 5 raised to 4. 2 and 2 is same here, bases are same, so add 3 plus 9 by applying the law again here, that is 2 raised to 3 plus 9, 3 raised to 3, then again 5 raised to 4, 3 plus 9 becomes 12, and simplify it. And if you observe here, there is 5 raised to 4 and there is 5 raised to 3, we can subtract 3 from 4, applying again the laws of exponent, that is a raised to m divided by a raised to n is a raised to m minus n. Apply this, we get 5 raised to 4 minus 3, then 3 raised to 3 minus 2, and 2 raised to 12 minus 12. Now simplifying, we get 5 raised to 1, 3 raised to 1, 12 raised to 0, 5 raised to 1 is 5, 3 raised to 1 is 3, 12 raised to 0 is 1, therefore the answer is 15. So this is how we can apply the various laws of exponents to simplify, and the procedure is clear. Now let us take one more example. Simplify 2 raised to minus 1 plus 3 raised to minus 1 raised to 2 into 5 raised to minus 1. Now 2 raised to minus 1 plus 3 raised to minus 1 square into 5 raised to minus 1. Now apply 5 raised to minus 1, apply this law here, that means it becomes 1 by 5, and 2 raised to minus 1 becomes half, 3 raised to minus 1 becomes 1 by 3. Simplify this, the LCM is 6, then 2 3 is 6, 3 2 is 6, therefore 3 plus 2 by 6, that means 5 by 6 square into 1 by 5. 5 by 6 square, again apply this law here, a raised to m, b raised to m, so it becomes 5 square, 6 square into 1 by 5. Now 5 and 5 base is same, so you can apply the again law, that means 5 raised to 2 minus 1 divided by 6 raised to 2, 5 raised to 2 minus 1 is 5, 6 square is 36, therefore the answer is 5 by 36. Remember that. We can also use the laws of exponents for expressing large numbers and small numbers, a very important method, and this is called as the scientific notation of large and small numbers written in exponential form. A number expressed in the form k into 10 raised to n is a scientific notation, where k is a number which lies between 1 and 10 and n is any integer. To understand this, let us take one example. Now we have a number here, a large number, that is unit, digit, 100,000, 10,000, lakh, 10 lakh. So we have got 34 lakhs 50,000. Now to write this in exponential form, we have to have the first digit as k, which is lying between 1 and 10. So rest all can be a decimal part. So 3.45 is the basic number we require, and therefore to place the decimal point exactly after one place, we have to count the number of places 1, 2, 3, 4, 5, 6, and therefore 3.45 into 10 raised to 6 is the exponential form or the scientific notation form of the given large number. And same way, we can write a small number in exponential form. Now if you observe here, we have to have the first digit as k, which is lying between 1 and 10. If I have to take 5, then we have a decimal part here, 14. To have a number 5.14 with 5 as k, which is the whole part, now we have to move the decimal point towards the right. So number of places to be moved are 1, 2, 3, 4, 5, 6, 7 and 8, and therefore 8 places to the right we have moved, and therefore it is 10 raised to minus 8. So therefore the number, this small number can be written in the exponential form as 5.14 into 10 raised to minus 8. That is how any large number or small number can be written in the exponential form, and please remember that. Now also we take one example here. If I have a number 5.4 into 10 raised to 6, that means I have to multiply 5.4 by 10 raised to 6. That means 1 followed by 6 zeros. When I multiply, then I get this value. That means 54 followed by 5 zeros. So this is the scientific notation, and this is a normal number from scientific notation. So also, if you have to write, let us say for example 0.0027 into 10 raised to minus 3, first convert this into exponential notation form. That means it is 2.7 into 10 raised to minus 3, multiply by 10 raised to minus 3, 10 raised to minus 3 into 10 raised to minus 3. When we add, we get 10 raised to minus 6. Therefore this number can be written as 2.7 into 10 raised to minus 6, which is the exponential notation form of the given number. And here also 7.3 into 10 raised to minus 5. 7.3 is 732 by 100, 1 by 10 raised to 5. That means it is 732. This is 10 raised to 2, 10 raised to 5 becomes 10 raised to 7, and therefore it is 732 into 10 raised to minus 7, and therefore the number is it is minus 7. That means 7 steps, the decimal point has to be placed 7 digits to the left. That means 1, 2, 3, 4, 5, 6, 7 and point. So the number is 0.0000732. So let us also understand how the powers of 10 can be used to express large numbers and small numbers, which are used in daily transactions. Now 1 lakh is 10 raised to 5. 1 followed by 5 zeros is 1 lakh. 100 lakhs is 1 followed by 7 zeros, that is 10 raised to 7. 10 lakhs is 10 raised to 6, that is 1 followed by 6 zeros, or we call it as 1 million. 100 lakhs is 10 raised to 7, or 1 followed by 7 zeros. 100 lakhs is also called as 10 million. And we have 10,000 lakhs. 10,000 lakhs is 100 crores. That is 1 followed by 9 zeros, that is 10 raised to 9, and that is also called as 1000 million, or 1000 million is 1 billion. So therefore 1 billion is 10 raised to 9. Now 100 crores is 1 billion, 1000 billions is 1 trillion, that is 10 raised to 12. So for our easiness, here we have 10 to the power of 1 is 10, 10 to the power of 2 is 100, 10 raised to the power of 3000, 10 raised to 4 is 10,000, 10 raised to 5 is 1 lakh, 10 raised to 6 is 10 lakhs, 10 raised to 7 is 1 crore, 10 raised to 8 is 10 crores, 10 raised to 9 is 1 billion, or you can also call it 100 crores, and 10 raised to 10 is 10 billion, and 10 raised to 11 is 100 billion. So these are bigger values. Now come to the smaller values. 10 raised to minus 1 is deci, 10 raised to minus 2 is centi, 10 raised to minus 3 is milli, that is 1,000th, that is milli, 10 raised to minus 6 is micro, 10 raised to minus 9 is nano, 10 raised to minus 12 is pico. Therefore, the powers of 10 are an important part of our life in transactions, in measurements, and any kind of calculations in every branch of science. We have this exponential notation being used. So that is what is the importance of exponential notation. So like that, we can use the exponential forms to represent large numbers and small numbers and for different calculations. So please remember this, and of course one more thing you have to remember here, 1 micron. 1 micron is 1,000th of a meter. That means 1,000th of a meter. Instead of saying this, we can even say it is 1 by 10 to 6 or 10 to minus 6 meters. So 1 micron is 10 to minus 6 meters, or 1 micrometer is 10 to minus 6 meters. So simple method of remembering and writing the small values. So that is the speciality of the exponential notation. So learn this exponential notation of writing the large and small numbers, and also remember the laws to be applied for calculation of scientific calculation of exponential numbers, and also to write a given number in exponential form and to write the exponential form in expanded form. All these basics are very much important for our higher studies, and these basics are very much necessary in mathematics calculations. Thank you.